Hello. Welcome to this video presentation where we discuss the axes in which an aircraft is able to move. There are three axes in relation to an aircraft. These are pitch axis, roll axis, and yaw axis. We will look at how the aircraft is able to be controlled in these axes, and how the aircraft is kept stable in the three areas of movement. Please note that we are not going into great detail on aerodynamics in this video, which is intended to just give a basic outline. Firstly, let's look at the pitch axis. The pitch axis is a lateral axis that runs laterally across the aircraft as shown. It is usually designed to be at the center of the aircraft. As the name suggests, the pitch axis is the axis about which the aircraft moves in pitch. In simple terms, pitch on an aircraft is where the nose rises and falls, as shown. We will now look at stability in the pitch axis. Clearly, we don't want a passenger aircraft unstable in pitch, so we have a design to stabilize the aircraft. The aircraft has a tailplane, usually at the back of the aircraft. The tailplane is basically a wing design that produces forces up and down. In level flight, these forces are equal. If an outside force, such as turbulence, moves the nose up or down, the forces produced by the tailplane change. In this example, the nose has been pushed up. The forces change so that the upwards force increases, and the downward force decreases. This pushes the tailplane up, which in turn pushes the nose down. Once the nose is back to the datum point, the forces produced by the tailplane equalize again, and the nose remains at its required position. The reverse is true for the nose dropping. The overall force from the tailplane pushes the tailplane down, which in turn raises the nose. Clearly, the pilot also needs control in the pitch axis. To give control, the tailplane is equipped with control surfaces, called elevators. The elevators are connected to the pilot's control column, and are moved by the pilot pushing or pulling the control column. The elevators artificially change the forces on the tailplane. This in turn pushes the tailplane up or down, which therefore moves the nose up or down. In this example, the pilot wishes to pull the nose up. The pilot would therefore pull back on the control column. This in turn moves the elevators up. This in turn changes the forces on the tailplane to give an overall force downwards. This force pushes the tailplane down, which in turn raises the nose. The reverse is true. To lower the nose, the pilot pushes the control column forward. The elevators move down, which creates an overall upward force on the tailplane. The tailplane moves up, so the nose comes down. The next axis to look at is the roll axis. The roll axis is a longitudinal axis that runs front to rear of the aircraft fuselage, as shown. It is usually designed to be at the center of the aircraft. The roll axis is the axis about which the aircraft rolls, left or right. This is where one wing drops and the other rises, as demonstrated now. As with pitch, there needs to be stability in roll, to prevent spilling the gin and tonics. In wings level flight, both wings are producing the same amount of lift, hence the wings remain stationary in the roll axis. If the aircraft is upset in the roll axis, one wing lowers whilst the other one rises. Due to aerodynamic design, the lower wing increases the lift it produces, whereas the higher wing reduces its lift production. Therefore, the lower wing rises, and the higher wing lowers. Once level again, the two lift forces equalize, and the aircraft maintains level flight. Once again, the pilot needs to control the aircraft in the roll axis. The aircraft uses roll to change heading, as this is the most comfortable and efficient way of doing it. To roll the aircraft, the wings are equipped with control surfaces, called ailerons. Like the elevators, ailerons can adjust the amount of lift force produced by the wing. The ailerons are connected to the control column, and are operated by turning the control column left or right. If the pilot wishes to roll the aircraft in a particular direction, the pilot turns the control column in the same direction. The ailerons on that side will rise, reducing the amount of lift on the associated wing. The aileron on the opposite wing will go down, increasing the amount of lift force on that wing. As a result, the wing will roll in the direction required. The third and final axis is called the yaw axis. The yaw axis is a vertical axis that passes through the center of the aircraft, top to bottom. The yaw axis is the axis about which the aircraft moves in yaw. In simple terms, the yaw of an aircraft is where the nose swings from left to right, as shown. As with the other two axes, the aircraft is designed to be stable in the yaw axis. To provide stability, the aircraft has a tail fin at the rear of the aircraft. The tail fin is a symmetrical wing designed to provide equal force on both sides. The idea is to keep the nose directly into the airflow. In this state, the lift forces from the tail fin are equal and opposite. If the aircraft yaws away from the center, the lift forces from the tail fin change. For example, if the nose yaws left, the lift force from the right of the fin reduces, and the lift force from the left of the fin increases. This gives a net force from the fin to pull the fin to the left. The aircraft rotates around the yaw axis to bring the nose back to center. As it does so, the forces from the fin rebalance. An aircraft moving on the yaw axis is probably the least comfortable of the three. However, the pilot still needs control of the yaw axis. For example, straightening the aircraft when landing in a crosswind. As with the other axes, we use a control surface. In this case we use a rudder. The rudder is situated at the back of the tail fin, and is operated by the pilot using rudder pedals. When moved, the rudder changes the lift forces on the tail fin. For this example, the pilot presses down on the left rudder pedal. The rudder moves to the left. This has the effect of increasing the lift force from the right-hand side of the fin, and reducing the lift force on the left side. This produces a net force that pulls the tail fin to the right, and hence the nose yaws to the left. The forces equalize when the nose reaches the position demanded by the pedals. Re-centering the pedals centers the rudder. This reverses the forces from the fin so that the fin is now re-centered, as described in the section on how yaw is stabilized. So, we have attempted to explain the three axes in which an aircraft moves. We described what they are, i.e., the pitch axis, the roll axis, and the yaw axis. We have described how the aircraft is kept stable in those axes, and how the pilot controls movement in those axes. Thank you for watching, goodbye.